Hello guys, hope you are doing fine. So today we will understand majority element problem. So what is majority element problem? Suppose we have an array and that array looks like 6, 8, 4, 8, 8. Suppose this is our array. So here the total length of array is 5. Now if any element occurs more than L by 2, that means here it could be 3, then that element will be considered as major element. Now suppose you have another array which looks like 1 2 1 3 1. So here the element number is also 5, and you can see like 1 actually occurs 3 times. So 1 would be major element. Now your array could be like also like 2 3 3 5 5 5. Here also we can see the element number is 5 and you have 5. This is happening 3 times. So that is going to be your major element. But if it is like 7, then 5 occurs in 2 times, but that is not L by 2 times, right? L by 2 is almost 2, so you can say like it's just L by 2, so it's not going to be our major element. Now if we are being asked to solve this problem to find out the major elements in O(n) time complexity, so how should we proceed? So there is an algorithm, that is a voting algorithm, which can help over here, and that algorithm has actually two parts. First part, we can decide who is going to be our tentative major element, right? So at the first part we will decide our major element, but we are not sure about it that this is going to be our major element. The second part we have to do is a verification, that whatever value we are getting from this part, that is truly ensuring that whether this element is going to be our major element or not, that can we achieve in the second part, which is the verification part. So let's talk about the verification part first. So suppose we got an element 8 through this first part, that for this array 8 is going to be our major element. Now if we iterate this array from I is equal to 0 to n and try to find out the count, then we can find like 8 appears 3 times. And if we see that whether it is bigger than L by 2, then we can conclude that yes, whatever we have determined through the first part of the algorithm, that is okay, or that is satisfying the need. So 8 is going to be our major element. Now let's come back to the first part, which is very interesting, which is very important. So let's dig into it. Let me first run the pseudocode. Suppose this code you can develop in Java or C++ as well. We have one integer counter, which is result, which is going to be the index, the final index probably. We can see when we proceed. So I'm setting it a default index, and that index is basically 0th index of this array, right? There is another counter or index we are taking, that is count, which is 1. And this count is not actually an index, this is actually a count of our element. And this count plays a very important role here throughout this algorithm. That exactly we we will see. Now we are iterating a for loop. We are running a for loop, and we are starting that for loop just like our previous example from the second element of the array, that means index number 1, right? This is our for loop, and this for loop we will iterate. With the help of this for loop we will iterate our value. Now there are three conditions which is going to happen over here. The first condition is if our current index, whatever current index means, we are talking about the result, the default index. If our default index value is equal to with our index value or not. If it is like the first element, so the second element is matching with the first element's value, then we can say that this could be our representative. This could be our representative who could be a leader or who could be an agent. So we will incrementing our count value. So this count incrementation of this count value indicates that the presence of this ith element ensuring that he has got power. He has got a power for being a leader, right? So we are actually counting the vote, right? So that is very, very important. And the second part, if he is not is someone whom we think that could be a leader, then that means if our result is not equal to the index, then we are saying he doesn't have the power, so we are decrementing that counter. So this decrement of count actually says that we are, whomever we think like he is going to be a leader, he is probably not the leader, right? So we are decrementing his value. So this is kind of a voting count, you can say. So we are reducing our count. Now the question is, there is a very interesting question, and that question is, if your count value is equals to 0, in that case what you will say? If your count is becoming 0, right? So that means it is not matching with these two conditions. Then you are saying, okay, fine, the whomever he is going to come, we can make him a leader. Whomever index we are talking about, he could be a leader, that's fine. And also we are ensuring that count is equal to 1. So in this way we can conclude that this is going to be our final role, and we can reset it and we can close this one. Let's move to the dry run. So suppose we have our first index, I equals to 0, not I equals to 0. In case of I is equal to 0, we will have count is equal to 1, and we have res is equal to 0, right? So that is the thing what exactly we have set initially here. In case of index number 1, I is equal to 1, what is going to happen? We have our count value, and that is going to be 0 because 6 not equals to 8. So that is going to be 0. And what is going to be our result value? That's very important. We have set no result over here. So that means result will remain no, whenever we are having count value 0, right, whenever we are having count value 0, then the result will be 1, right, and count would be also 1. I is equal to 2, the second case, when we have, so this is 0 1 2, index 3 and 4. So when I is equal to 2, that means we are comparing it with 8, right? So initially the count gets decremented and it becomes 0, but at the same time the count is going to be 1 and result is going to be set 2 because he is a new member having count 0. This condition is going to be fired and we are resetting it. In case of I is equal to 3, I is equal to 3, we got 8. So in this case we will have count initially 0 because that doesn't match with 4, but at the same time the count will get reset 1 through this condition and result will become 3. In case of I is equal to 4, the count is going to be 2 because you got 1. This condition will get fired and the result will be what? 3. Yeah, so that is the thing what where the final thing is coming when we are talking about this algorithm. So it gives us like the value is 8. Thank you so much. If you have any comments, please write in comment section.